Hi, this is Paras from Get this side. I hope you're having a great session, learning different areas, different platforms, different technologies in the HashiCorp securely building. And here I am covering another great aspects of AI ML, where how we can secure and create a resilient network foundations so that our AI and ML platforms can work seamlessly, securely, and reliably. So while we fuel the innovation with AI and ML, we want to make sure that the network foundations we have set up is pretty much strong, secure, and safe. With that in mind, here we have a couple of opportunities in AI and threats in AI that we would like to start with. Then we are going to talk about the network, which is the unsung hero, or you can say the critical aspect, which often gets missed out. Following which we are going to speak about a strong cloud foundations, followed by high performance connectivity and why it's required. Then we are going to give you a brief about the network security and zero trust, followed by a practical hybrid pipeline using cloud providers like GCP, HashiCorp, Terraform, along with a reference architecture and the next steps that the audience attending this session can actually go through. We have seen over the course of time, like every time there has been a new technology that has come up, we have seen a great transition. There has been some initial challenges, there has been some initial bottlenecks, but eventually once we have done that transition, the impact, the usefulness, the challenges that technology has helped to sort out has been of very great help. For example, when the mobile telecom technology came, it had a great impact where a lot of complicated ways, or you can say the traditional ways of how connectivity used to be done, was simplified. Then came the internet boom, where with a click of a button, people were able to send emails. With the help of social media, people were able to connect across different users across different countries. They could engage themselves in different community forums. And similarly, when the cloud computing came, we see a transition from on-premise hardware infrastructure to the cloud infrastructure, where the companies now were more focused towards the business problem, the business challenges, the problem statements they were working towards, instead of focusing on the background infrastructure like uh, purchasing the hardwares, setting it up, and then managing it up. Now, once the cloud computing came, all of that was abstracted and handed over to the cloud providers, with the interested companies only being focusing on their core problem statement, their core business problem or business statements that they want to simplify. All these transition had their own pros and cons, and eventually as they matured, the things became stable and we are seeing a great uses for each of them. Similarly, the fourth transition that we are seeing right now is for the artificial intelligence, where we can see how the complicated tasks are being simplified. In fact, you can even observe that one reason for the artificial intelligence doing wonders is probably because of cloud computing, because the heavy infrastructure which previously otherwise used to be handled by the folks or by the users on their on-prem now can easily be provisioned as an on per demand using any of the cloud providers. For example, like GPU, TPU in GCP can easily be provisioned as in when a user wants, they can quickly get start, bring up an instance, set it up, and then continue to use it. So this is the beauty of how the artificial intelligence has worked incrementally and is helping users to simplify a lot of many things. And we see how useful it is. However, with every new transition or new technology comes a threat. And in this section, we are going to highlight the threats which are specific to the AI. These threats can be categorized into four categories. We call it as model, application, infrastructure, and data. So by model, we refer to the threat which is, you can say, specific to the model manipulation and evasion, like doing the prompt injections where someone can craft malicious inputs to language models. and exploit vulnerabilities. Similarly, model evasion, where an adversarial attacks involving some perturbations of input data or uh, like uh, doing or designing or intentionally doing the model to misbehave, to provide misclassified data or unexpected behavior, or even like insecuring the model output if output filtering or monitoring are inadequate. So AI models can generate misleading or offensive or even at times unsafe data, which is something that none of us would be looking for. And this is where we should make sure that this threat is handled well in advance. The next threat we will be talking about is the application compromise. For example, one common use case of this is denial of ML service, where our service, which is providing us the use case of ML application, is unable to serve or provide the, you can say, unable to provide us the response or the functionality that it was designated to, where manipulation of the resources or overloading the AI system had made the service unavailable or disrupting the operations that rely on AI output. Now, this is where this is a threat on the application pillar, which compromises the functioning of our AI use case. The third one that we are going to talk about will be the infrastructure for AI, where let's say some cases of it could be the model backdooring, where let's say a user while training, or let's say uh, um, with a malicious intent, someone while training the model had provided or injected a hidden trigger that allows an attacker to manipulate the model's behavior with specific inputs later on. So once the model has been trained and everything is ready, during the training they injected it with a hidden trigger that it behaves in a certain way when injected with an with an input, and that behavior is something the uh, which someone then tries to use when the model is functioning. So things like this is something that we should make sure that infrastructure for AI is also pretty much secure, and the model is handling this pretty nicely, and all the infrastructure which revolves around, whether be it during the training, during the ingestion, or during the inference, are being appropriately safeguarded. The fourth pillar we're going to talk about will be the data exposure, which is another critical aspect, because the data is the new IP, as we often say in the AI ML world. So we have to make sure that the sensitive data leakages are always being handled. The inferred sensitive data or the data in the model poisoning is being avoided, where anyone who tries to inject malicious data during the training or retraining to degrade the model performance is detected well and early to create any hidden backdoors. So this is something which strictly should be avoided, or at least some safeguarded measures should be put in place to avoid such scenarios. And the last one will be the in the same data exposure, I would say, is like how to have or avoid unnecessary storage of data used to train AI models, which can create legal and ethical risks. These are some of the threats that we should make sure that we are handling well in advance for the uh, to have like a pretty good AI model functioning. While all these are all the threats that you and us are discussing for creating a robust AI ML platform, but network has been like the slide says, unsung hero, which often acted as like a critical bottleneck if not handled properly. So AI ML is something we'll say has been powered by data, and this data is like a large amount of data in huge chunks, and this data is something which travels a lot. It travels from one component to other. It travels in millions of tokens, and uh, for this travel to happen perfectly, if we have a poor network design, then it will eventually lead to critical bottlenecks like the data will be transferring slowly. We can expect some training failures. We can see certain times outages. We can even see not being able to conclude or provide an inference well in time. So these are some of like very basic things, but are often misjudged. Like while we are planning or thinking about AI, it's not only about AI. It is AI on top of the existing infra, existing network, existing security that we have provided, we have built in. So there's something that we should definitely have well in advance. For example, like if we are planning to build a strong cloud foundation, then things like zero trust architecture, network segmentation, firewall rules, VPC, security groups, IAM permission, encryption, high bandwidth connectivity, all of this should be catered well in advance, or at least should be thought or brainstorm or uh, should be handled or is something that should be there in our discussions from the very day one. We spend so much time on models, algorithms, but what about plumbing? So this is the slide that sets the stage that where what are the strong cloud foundations which one must use to plumb all the necessary components together. So zero trust architecture means we only provide the necessary permissions. We only whitelist the necessary firewall rules which are required. The network segmentation, we logically isolate the network which is being used for AI ML workloads and ensure that it only have the necessary firewall rules, the IAM permissions, which are going to be used for that reason. Same is the case for IAM permission, where we are whitelisting the IAM rules or providing the users with the appropriate access for which only they have or they require read and write permissions. So with that in mind, the next thing that we have is encryption in flight and at rest. So this is again like this can be achieved in form of encryption, or we can even use confidential computing to ensure that the data that we have, whether it's in transit or is it in at rest, is always encrypted. And the last point that we have is a very important point which talks about high bandwidth connectivity. So what do we mean by high bandwidth connectivity is the data which flows in large chunks have sufficient capacity that the high bandwidths are supported, or the transfer rate for huge requirements can easily be upgraded it to. Like if our network is strong enough, or if we have designed an architecture that can support connectivity across on-prem, different cloud providers, then it's going to ensure that the bandwidth is not going to be a bottleneck for us going forward. Some of the problems for high performance connectivity, as I have to say, is like if we don't have thought about this, if we have not connected this problem statement, then the large data sets that we have is going to take forever to move. So the way to address this is you can use cloud interconnect for high bandwidth connection. If you are trying to communicate from GCP VPC to on-prem or to any other cloud provider, if we are using it for internal communication, you can try out using Private Service Connect, you can use VPC peering, you can use various similar ways or within VPC connectivity to ensure that a very fast data transfer rate is achieved. Similarly, the network security and zero trust that we briefly covered in our previous slides, we intend to say that zero trust means that no service by default is expected to have permission, or basically like no service is trusted by default. So the way it's implemented is we create specific least privilege rule for traffic flow. And similarly, every service gets a unique service account and we only grant only the permission it needs. So it's like a bare minimum permission that it it will have that is required for it to achieve or to have its functionality. So this is how we achieve the zero trust and network security by using the our traditional way of securing our infrastructure. Now we're going to say like how this practical hybrid pipeline can be achieved. So we have a reference architecture, but the way this has been achieved is we we provision the entire infrastructure using HashiCorp Terraform. And the reason for this is like there are certain set of guidelines, certain set of best practices, certain set of rules that we just discussed, whether it was securing the infrastructure by zero trust, by restricting the IAM permissions, by setting up the firewall rules, by creating cloud interconnects, or by means of ensuring that the resources that we have, the data that is being transferred, it's always encrypted. So all this is configured by using reusable and repeatable code, infrastructure as code by using Terraform at its core. This helps us to write reusable, repeatable code that helps us to provision the necessary infrastructure for deploying or for creating AI/ML workloads. So this then can actually be used to write your development environment, which you can then further uh, move it to the next stage for your pre-production environment, and then eventually, if everything seems fine, you release it in the production environment. So that's the beauty of HashiTalk's Terraform, where you can write reusable, repeatable code, which you have tested to create secure network foundations, and which then eventually you can identify any loopholes, if any. You can fix them in your dev environment, release it into your next stage, which is pre-prod, and then eventually releasing it to the prod. So this is where this repeatable code plays a key action. Now, the architecture that we are going to talk about covers the data ingestion, where you can actually stream the data from on-prem via interconnect and then save it securely in the cloud storage buckets. Uh, the last one is we can use a Vertex AI service. Like in this case, in this example, we have used an offering by GCP called Vertex AI Vector Search, but you can use any of the services, any of the service as per your requirement, as per your use case. But the focus here is going to be majorly onto your networking foundations, onto your networking block, so that it can actually support or scale to your different uses and needs. So here is a quick reference architecture of what we want to try to speak about this network foundations. So starting from the left, you can see we have cross-cloud interconnect, cloud interconnect, and cloud VPN, all connected to NCC logical hub, which then sends traffic to your on cloud, which is in this case is Google Cloud Customer Host Project. So this is the core crux of our networking foundation, which we have done to ensure that your project in the Google Cloud, which is the middle box, the customer VPC project, has the ability to connect to your on-prem compute resources, your compute resources in other cloud providers, as well as in any other third-party data centers. So this helps you to not only like you can start small where let's say you only have your data present in the on-prem. So from on-prem to HAVPN or from on-prem to cloud interconnect helps you to establish connectivity with the Google Cloud Customer VPC project. However, if you want to further scale into bigger use case, you can then reach out to any of the cloud providers, use the cross-cloud interconnect, and via the existing setup, you can easily scale your computation because as the demand grows, as the workloads grow, as the data grows, the requirement for the compute resources, GPU, TPU, will eventually also grow. So having the adaptability to support multiple clouds, multiple data centers, on-prems, appliances is a very critical aspect in this. So in this example, you can see we can say an on-prem connects to the NCC logical hub via cloud interconnect, which then helps to establish the connectivity to the Google customer managed Google Cloud. And for the example, the red arrows denotes the request being routed for the Vertex AI vector search. So think of this diagram as a plug-and-play model. Like on the extreme left, you can choose cross-cloud interconnect, cloud interconnect, HAVPN, either one of it or all three of them based on your requirements and your connectivity, where your workloads, where your data resides. And on the extreme right, we have taken an example of Vertex AI vector search. Now this could be a case where this is not necessarily that you're looking for this service. You may be looking for some other services in Google Cloud, or you may be looking for some other service in any other cloud provider, in which case you just replace this block, this module, with the block or the module of other services sitting in other cloud provider or on-prem. So this is like a plug and play model. You can easily replace any of the services with other service of your offering, but the networking is the main part which remains the same. Now we have got this implementation for you with us as well. So we knew that this is the complicated part. This is the interesting part. So the way you can actually try to do this is, it is like a very, I'll say, mundane task to do it manually. To like you can do it once, but every time you have to set it up again and again and again using console or any CLI, it is going to become a very, very tricky job to do. So the best way to do this is with the help of Terraform, and this is where the next steps is will be there for us. So we have intentionally broken it down into two steps. So you can see each of the step is eventually going to land you to a GitHub README page, which is an open source repo. And what it helps you to achieve is it gives you a detailed guide of how this automation using the Terraform works. So the step one helps you to set up a secure hybrid network connectivity, and you can either connect at the on-prem or other cloud provider using NCC, which runs in the GCP. So this is where you can say the networking backbone resides. And once this step one is set up, then you can actually move on to the step two, where you can either use Vertex AI vector search over this network that you have already set up in step one, or you can replace this step two with any other services or any other use case that you might already have. So think it of a way where step one is a mandatory, while step two is something that if you want to implement the same architecture, you can do that, or you can try out any other services. So we have a bunch of services already in the same repo. You can try any of it, be it Cloud SQL, AlloyDB, Vertex AI Workbench, Vertex AI Online Endpoints, and many other services, to name a few. So, or if you have any other requirement for any other services which is expected to work with any other cloud provider, so you can do it yourself. These are some of the combinations that you can try it out. However, if there is something that you need explicit help on, or if you're looking forward how that can be automated, you can probably try to raise that as a GitHub issue or tag me out there, and we can see how we can work together to bridge that gap. But this is pretty much what I had in setting up your secure cloud networking foundations for your AI ML workload. I hope this session was of interest to you, and looking forward